Okay, surprise, we're not done. I didn't look, there was the last page. All right, let's practice a little bit more with this factoring when there are three terms. So again, the first thing we're going to do, and I am on page 30 in the skinny packet, is I'm going to make my x. And I'm going to multiply the outside terms when it's in standard form. And my middle term will go on the bottom. And then from there, I just want to find my factors of 14. So here they are. And I want to check which set of factors will get me to 9. And that is going to be the 2 and the 7. So again, I'll put 2x and 7x. The reason why I'm putting the x's one more time is when I add 2x and 7x, I get the 9x. And when I multiply these, the 2 and the 7 give me the 14, the x and the x give me the x squared. So when we are factoring, again, this is standard form right now, and we're about to put it into factored form, we are finding who the neighbors that met to give us 2x squared. So what we are looking at is what neighbor will met what neighbor to make 2x squared, and that would be 2x with x. Then I use these side numbers to help me figure out the rest. So I draw a loop, and I draw a loop from 2x to the other parentheses, x to the other parentheses. And now I check, can I multiply something by 2x to make 2x? And I can, a positive 1. And then I go to this one, can I multiply x times something to make 7x? And that would be a positive 7. So we have now found the neighbors to meet the neighbors to make 2x squared plus 9x plus 7. So just a reminder, I'll show you once. When the neighbors meet, we get 2x squared. We get a 2x. You can kind of start to see these pieces happen. Then 7 goes to meet the neighbors, and I get a 7x. And then 7 goes to meet 1, and I get 7. And when I add this up, I get 2x squared, I get 9x, and I get 7. Let's try the next one. So we're going to make our x. I'm going to multiply the outside terms for 24x squared. And then the 10x goes in the bottom. And here are my factors of 24. Whoops, but I miswrote one of those. That's not a 24, that should be a 12. And now when I look, there's actually two possibilities of that can get me to 10 and to 24. And so we're going to be using the 4x and the 6x as our correct pair, because adding these gives me 10x, multiplying these gives me 24x squared. So again, we're about to create the factors. Again, we're going from standard form to factored form, and we always start with what neighbor met what neighbor to make our first leading term. To get x squared, it would just be an x and an x. And now I'll focus on the side numbers to get the rest. So I draw my loops. And can I take x times something to make 4x? I can. That's a plus 4. Let's put that little note up there. And can I take x times something to make 6x? I can. That is a positive 6. And now we have our factors. If this neighbor to meet this neighbor, we will get the standard form. And the last one. So on the last one, let's start to take a look at what I mean by factoring completely. So the other two did not have that, and I probably should have brought that up, but it didn't. So the first thing whenever you factor completely is you do want to look for a GCF. Is there a number I can factor out of all three terms, and is there an x or x's that I can factor out of each term? So all the terms don't have an x, so I won't factor an x out, but I could divide or factor out a 2 out of all of these. So 2 is what we're going to call the greatest common factor, and when I divide or factor out a 2 out of all of these, this becomes x squared, because 2 and x squared is that. 2 with a minus 2x would make the minus 4x, and 2 with a positive 5 would make the 10. So now, again, we're factoring completely. And so from here, this has 3 terms. I'm going to make my x. So are there factors of 5 that can get me to negative 2? And the only factors of 5 are 1 and 5. And if I try to put 1 and 5, there's no way I can add and subtract these to get to here. So this is as far as it gets. This is factored form. We have a GCF as one neighbor, and then we happen to have a trinomial as a second neighbor. And that's it. This is factored form. So the last type we're going to talk about is a special thing called a difference of squares. And so I'm surprised there's not just this like general format, but we'll put it up here. So a difference of squares has a general formula that looks like this. The reason why it gets its name difference of two squares is because difference is the subtraction sign that you see here, and the squares because the terms have a nice perfect square root. And once you figure out those square roots, they can help you quickly fill in your factors or your neighbors. So for instance, if I were to take the square root of a squared, this square root cancels out this squared, so you're just left with an a. And if I were to take the square root of b squared, the same thing happens. This square root cancels out the squared, and I'm left with a b. And once you know their square roots, they can become the terms inside your factor connected with one addition and one subtraction. So let's take a look. As soon as I see two terms, I want to see is it a difference of two squares. So the subtraction meets the difference, and can I take the square root of these? So the square root of 81 is probably the simplest one. That's a 9. And if you take the square root of x squared, just like a squared and b squared, you will just get x, just like we got a and b. And since this has met the definition, x and 9 can become the terms in my factors, and I'll put 1 plus and 1 minus. If this neighbor were to meet this neighbor, you would get x squared. So let's just walk through that. There's x squared. There's a minus 9x. And now 9's going to go meet everyone, which I'll stack with its like term. And then when these neighbors meet, you get minus 81. And so when you combine these, those will cancel out, so you just have the minus 81. And that's our difference of squares. So on this problem, what I'm noticing is I actually have a GCF. I can't factor an x out of both of these, but I can take a 2 out. So there goes my GCF. And when I take the 2 out, I'm left with a 4x squared. And when I say take the 2 out, I'm dividing the 2 out. And when I divide this or factor out a 2, I'm left with 9. So now I'm going to check this part. And this is actually a difference of squares. There's the subtraction. And if you take the square root of 4x squared, well, you should know the square root of 4 is 2, and you should know the square root of x squared now is x. And if you take the square root of 9, you get a 3. So 2x and 3, so I'm going to drop this GCF down. I can make more, and this, more factors that is, can turn in, put my 2x and 3 as my terms, and then have addition and subtraction. So this set actually has 3 neighbors, 2, 2x plus 3, and 2x minus 3. Last one, is there a GCF? So I don't see anything that I can factor out of both of these, but I do see subtraction, and if I take the square root of 4x squared, again, square root of 4 is 2, square root of x squared is x. If I take the square root of 49, I get 7. So this meets the conditions of a difference and then of squares. So this can factor, or we can find the neighbors. Again, these become the terms in our factors, and you put a plus and you put a minus. And you can put the minus first and then the plus. That's totally up to you. So that, I believe, completes section 8.1.